Okay. So what we'll do today, okay, so the homework assignment is due already. So guess that's another reason why some people may be late. So the first thing I'm going to do is to go over the homework assignment just to make sure that we understand the solution to the homework assignment. And then we can either talk about exam one if there are enough people, who want to know the answer to exam one, or we can move ahead and continue to talk about binary search. Okay, so we'll make a decision at that point. All right, so homework first. Yes, I am recording. Thank you for the reminder. And here we go. Okay, so the homework assignment is, Ray 1 is the one that's due today. So let's go ahead and take a look at it. All right. So there are a few things that are kind of important in the syntax. This is a square bracket. It is not a pair of braces or parentheses. Okay, so you have to use the correct notation or the correct syntax when you refer to a particular element in an array. I'm not going to take a lot of points off, okay, but I will take some points off just to make sure that we understand what is the correct syntax. All right, so I am going to go to the Google Drive for this class and then basically start a document of today's date in it. So this way you can actually look up the solution after class if you want to. So I go to the share folder and just create a file of today's date, and it is a spreadsheet. Okay, so it's the easiest way to trace an algorithm because it's just a table. So I would name the spreadsheet in today's date, 2025-0312. So now if you want to, you can actually open this document on your side, and you can then take a look at it on your own computer. All right, so I will do the usual thing, which is going back to the assignment, and I am going to copy and paste, take a screenshot, of the algorithm itself. And so this way I can display the algorithm when I'm working on it. All right, so this is going to be always on top. Just kind of stash it at a corner, and now we can start to trace the algorithm. Now so we have line number. Okay, so at this point, I think we should be fairly familiar with all the mandatory columns. There's a comments column, but that's usually all the way to the right hand side. And then we have x as a variable in this case. Sorry, yeah. hmm I'm not sure what you mean by that. What? How about this? Let me trace it first, then you can compare your solution to the one that I'm going through. Yep. Okay. So Um, and in the algorithm, it doesn't even need an n, okay, because it is not actually needed in this case. Now, if you say, oh, but it is conventional that we have a variable called n and it is reflecting the number of elements in the array, that's fine. You can have the additional variable n that is not even referenced a single time in the algorithm, okay? But that's okay if you do it that way. And then we have array A. Okay, so we have A bracket 0. Okay, once again, this is a bracket. It is a square bracket. It is not a curly brace nor a round parenthesis. Okay, so you have to use the correct notation. So in this class, if you use the wrong notation, if I still understand the code, I can give you partial credit. But if you are to write the actual program and you use the wrong notation, the program is not going to work. Okay, so just kind of keep that in mind. All right, so I am going to make these columns a little bit narrower, like so, and the comments can be a little bit wider. There we go. All right. So the algorithm or the homework assignment did not say about any assumption, but if you want to, because you have variable n here, this one is going to be 5, but once again, we don't really need column C, okay? If you have a column C here, as variable n, that's fine, okay? But we don't really need it. N usually is the name that I use to reflect the number of items in the array, but we don't need it this time. No, you don't have to. But if you put it here, it's okay. I'm not gonna mark any points off because it's just not referenced. Usually that's how I use it. Yeah, that's usually how I use that name. Yep. Okay, all right. So now we start tracing the algorithm. So I can put this a little bit closer just so that you don't have to, scan, all the way to the right-hand side to see it. So on line one, x is updated to a value of 2. And then on line 2, we don't do a single thing. Now, if you trace line 2, which is just consisting of the word do, I'm not gonna take any points off, but you don't have to do it. Okay, you just basically skip all the way to line 3. So on line 3, we have to compute 5 minus x first. 5 is 5. Okay, x has a value of 2 right now. 5 minus x is 3. So that means the right-hand side of the assignment on line 3 is 3 itself. Where do we store the value of 3? We store it to a bracket x. X currently has a value of 2. So a bracket x is referencing a bracket 2, which is column F. So column F is the one that should be updated to a value of 2. So I'm going to pause here to see if there are any questions because I think this really is the essence of the program. Yes, 3, you're correct. I cannot do subtraction. That is correct. So this is supposed to be 3 because it's 5 minus 2, which is 3. Thank you. All right, and then on line 4 is a little bit tricky, but not exceptionally so, because it uses an operator that we normally do not use on a daily basis, which is finding the remainder of a division. So in this case, I'm adding 3 to x. So x is 2, 2 plus 3 is 5, and then we're looking at 5 divided by 5. But I'm not looking for the quotient, I'm looking for the remainder. So modulo, exactly. So what is the remainder of 5 divided by 5? 0. 1 is the quotient, 0 is the remainder. Okay, so that's how x is updated to a 0. And then on line 5, we have to evaluate the condition. So now we go like, okay, x does not equal to 2. Is it true or false? It is true. X does not equal to 2 is true because x has a value of, what is the current value of x? It has a value of 0. That is correct. Now, where do we go? Because this is a do while loop, so what is the next line that I need to go to? Hmm? Line 3, that is correct. Okay, now if you go to line 2, I'm not going to take any points off. Okay, but there really is nothing to do on line 2. Okay, line 2 serves only for the it serves only the purpose of marking the beginning of the loop, but it does not do anything else. So we don't really trace line 2. So now we go to line 3 again. We have to compute what is 5 minus x. 5x is 0. 5 minus x is 5. Okay, so the right hand side is now decided. Where do we store that? We store it to a bracket x. X has a value of 0, so it is a bracket x, which is column D, that is getting a value of 5 this time. Are we doing okay so far? Okay, great, good, good. Now we get to line 4. Line 4 is going to update x. So we are computing x plus 3. X is 0 right now. 0 plus 3 is 3. We're looking for the remainder of 3 divided by 5. And what is that? It is 3 itself. Very good. So now it's updated to a value of 3. We go to line 5. Line 5 is asking x does not equal to 2 is true. Get exactly, because 3 does not equal to 2 is true. So we go back to line 3. Okay, so I think most of you know what's going to happen next. So when we get back to line 3, we are now computing 5 minus 3, which is a 2, and then we have to store the value of 2 to a bracket 3. A bracket 3 is column G, so column G is the one that stores the value of 2. Okay, and then we move on to line 4. So this time we have 3 plus 3, which is 6. 6 divided by 5 has a remainder of 1. That is correct. So we get to line 5 again, and then we ask, oops, wrong line. There we go. X does not equal to 2 is true because X has a value of 1. 1 does not equal to 2 is true. And then we go back to line 3 again. And this time we have 5 minus 1, which is 4. And then we store the 4 to a bracket 1 because X has a value of 1 right now. That is column E. So column E is the one that stores a value of 4. And then we move on to line 4. 1 plus 3 is 4. And then 4 mod 5 is 4. That's correct. So now we move on to line 5 again. And X is 4, does not equal to 2 is true. And then we go back to line 3 again. And this time we compute 5 minus 4, which is 1. And then we store the value of 1 to x bracket x. X is 4 right now, so we are storing that to a bracket 4, which is column H. It stores a value of 1 in this case. And then we get to line 4. 4 plus 3. Oh, wait. Did I do a... No, I think I did something wrong. Sorry? I think I did something wrong. Okay, let me just double check. 0 plus 3 is 3. 3 plus 3 is 6. 6 mod 1 is 1. 1 plus 4 is 3. 1 plus 3 is 4. And then, hmm. Okay, I think it's good. Yeah. So 4 plus 3 is 7. 7 mod 5 is 2. Okay. And then finally, we get to line 5. I was suspecting that I did something wrong, but I did not. Okay, it was done correctly. So 2 does not equal to 2 is false. And therefore, we get to post. And that concludes the entire trace. All right, so do we have any questions about this particular trace? Okay, all right. Yep, well, I'm going to give you a very annoying answer first, and then I'll answer your question. You can watch the video and find out because you were late. But the answer is it is not needed. Some people just go like, oh, it is kind of conventional that we use variable n to indicate the number of elements in the array, but we don't need it in this algorithm. Hmm. All right. Any other questions about this homework assignment? Nope. Okay. How long did it take you guys to do the homework assignment? It took me about what, 10 minutes or so, 15 minutes or so to kind of do the whole thing while explaining the whole thing. Yep, go ahead. Hmm? 30, 20, 30. Okay, half an hour. Okay, that's fine. Okay, because that 30 minutes is not really just for doing the homework assignment. You're actually studying at the same time, okay? Because every time you look at a line of code and you have to figure out what it's doing, you're helping yourself to you're helping to remind yourself, of what is array indexing or what is the mod operation. So it's actually studying, while you're doing your homework. Okay. Any other time frame, that is entirely different from 30 minutes? Okay. Hmm? 15-ish. Okay, that's about right. Okay. So, for different people, it might take a different amount of time. Some of you might have taken a few classes in programming before, so it's a little bit faster for you because you have some exposure to these concepts already. Some of you are, exposing to programming the first time in this class. So that means, you're going to take it will take you a little bit more time. Okay. But remember, for every hour in lecture, you're supposed to spend 2 additional hours. So we spent 80 minutes on Monday to talk about this. So that means, between Monday and now, you should have spent, okay, on the average, a total of 160 minutes, and if this is only taking half an hour, it's not bad at all. That'll be good. All right, cool. All right, so this is out of the way, and so now we have a choice. So we have a choice to talk about exam one because I can go over the answers of exam one, or we can continue to move forward to talk about binary search. Okay, so I can see most people, I can see that's a consensus. I don't see anyone, objecting to going over exam one, like, with a passion. So let's go over exam one. Okay, so let's do that. So I'm going to close this because I don't need that anymore. All right, so I am going to use a particular example. So I have many versions of every exam question. So each one of you is probably getting a different version. All right, so I'm going to pick variation one, okay? So this is variation one, which means, it is not going to be exactly the same as the one that you have, but it has very similar questions, okay? The styles are all the same. It involves the same line of reasoning, except, there are many little differences where, it's a little bit harder for someone to copy the answer from somebody else, or it would have left some traces to get me to be suspicious. It's like, how come this answer is correct, but not for this particular exam? Hmm, that has happened in the past, by the way. All right. So this is the question, and then I will also open up the key, which you also have access to. All right. So what was I talking about? That you both have the scanned version of your exam and also the key to your specific exam. What was I referring to? And also how I scored your exam. Okay, so every single question, every single part, there's at least I give you a number of what you get out of four for each part of each question. So where do you find all that? Nope. The shared folder. I shared a folder with you probably this morning. Okay, so you need to go check your Google Drive for a shared folder that has your student ID as the name of the folder. So in that folder, you will find a scanned copy of your exam. It will have a copy of the key to your specific exam, and also a Microsoft Doc, no, not Microsoft, Google Docs. It will have a Google Doc that explains how many points you get for each part of every single question, and also the total. So you should have those three documents in your folder. All right, so we'll go ahead and talk about this on a drive that on a folder that I shared with you. You got it? Okay. Yep. So if you go to your Google Drive and look for files that are shared with you, you should probably find it there. If not, you can go to your apps.losrios.edu Google Drive or Google account and then search for your student ID, and you should see that too. Is that okay? Okay. I can help you after the class. Okay, I can help after the class. So, assuming that you get variation 001, but the variations are not really that different from each other. Um, so the question is, in question number one, is I give you a trace and then you have to give me the algorithm that produces the trace. So now the question is, how do we analyze this? Okay. And I think a lot of people get the explanation partially correct, but there are only two people, I think three people in this class that got it right completely. Okay. So when you analyze this code, you will see that there's repetition. In other words, you can see line 34, line 35, back to line 34, and then line 35, back to line 34, and then back to line 35. So we know there's a loop involved, okay? Because other than loops, there's no way, well, okay, of everything that we have talked about so far, other than loops, there's no way to go back to a certain line and do something again. So we know it's a loop. But once we know it is a loop, you have to find out what kind of a loop it is. I tried my best to give you a clue because I give you the three possible control structures here. Most people still use while because I guess partially because in the practice exam it was a while loop. But in this case, it is not a while loop. The reason why you can tell it is not a while loop is because the decision is made after the operation. In a while loop, you decide first, you evaluate the condition first, and then you perform whatever action is associated with the loop. So that distinction between what a do loop is and what a while loop is was only people in this class was able to make that distinction and identify that this is a do loop and not a while loop. Is that okay or not? Yes. Hmm? Right. Based on this, right? Yep. So based on that, you also know, yeah, you also know what the condition is. The condition is already spelled out here. While u is less than 24, but you have to say do something, okay, while u is less than 24. That something you kind of have to deduce it from how the value of u, in this case variable u, is changing to figure out, okay, how can the same line be updating variable u to 19, then 23, then 27? What do you think? Most people got this part right, by the way, figuring out the assignment statements. The assignment statement that is supposed to be line 34. So what is line 34 doing? Yep, u equals to u plus 4, okay? Some people only say u plus 4, okay? But that is not the correct answer. You can compute u plus 4, variable u plus 4, all you want. But if it is not on the right-hand side of an assignment and the left-hand side specifies variable u, that expression just computes a value. It doesn't store it anywhere. So u equals to u plus 4 is the correct answer. Okay? So I also found that many people did not give me code. They gave me something that looks more like a trace, except each line is replaced by a statement. That is not algorithm. That's still kind of like it's kind of like a weird mixture between a trace and an algorithm. So so that's so those solutions also do not get full points. They get partial credit. All right. So the answer, okay, if you want to reference the correct answer and how the reasoning goes, it is in the key. Okay, so the key file contains the actual explanation. Are we good so far? Okay. All right. Yep. Yep. So some people just write down this portion without the u equals to. So I cannot give a whole lot of points to that one because it has to be an assignment in order to update something. All right, so that's question number one. And then question number two is fairly straightforward as a trace. So there really is not much to explain other than, you just have to trace it. Now, the tricky part of this particular algorithm, I don't think it's really tricky, but some people may see it as, oh, okay, that's a little bit tricky, is we have a conditional statement inside a while loop. So in other words, it is a nested control structure. So the question now is, what if line 7 evaluates to false? If you get to line 7 and the condition is false, what is the next line to execute? Line 9 is correct. Yes, because we skip over the then statement, which is line 8, then we go to line 9. Some people misunderstand that if this condition is false, we exit the loop. So that is one misunderstanding of some people. Other people, basically assume that line 9 and line 8 are both part of the conditional statement. So when the condition of line 7 is false, we go back to line 6. That's another misunderstanding with this particular question. But most people got this question right. Okay, this is the question that where most people got it right, almost 100%. And the key is also in here. Okay, so you can see that this is the trace, and this is what the trace should look like. So do we have any questions about question two and the answer to question number two? No questions. All right. Then we are going to move on to number three, which is I guess, one of the more difficult questions. Between question one and three, I don't know which one is more difficult. Um, if you ask me, I would say question one is probably a little bit more difficult because you have to go backward to try to figure out what kind of statement it generates the trace. This one is still fairly straightforward, but you have to basically perform an analysis of how we can possibly get to the line that um, that will influence, or it will put a value of 2 in y. Okay. So in the exam, okay, for those of you who took the exam while on that date, I put an X here, and then I put a correction on the projector, and some people came up to me and go like, okay, is that what you want to change? And I go like, yep, yep, this is the one that needs to be changed. So in this one, it is already fixed. Okay, so we are asking, assuming variable u can start with any value you choose before the algorithm starts, is y equals to a possible post condition for this code? Explain your answer in the following space. So that means the first thing to answer this question is a yes or no, a true or a false, whether it is possible or not. The only way to guarantee that y ends up with a value of 2 is to execute line 51. So the question really is asking, can we get to line 51 if you have basically the freedom to put a value into variable u to begin with? You can put any value into variable u. The question is, can we get to line 51? Now, the answer is, it's not always yes. Okay, in this particular question, it is yes. Okay, so now you have to go backwards and figure out, how do we possibly get to line 51? So to get to line 51, it is the else of this conditional statement, of this condition. So we need this condition to be false. We need variable u to be greater than or equal to 71. Does that make sense? Greater than or equal to 71. Because it is in the else part of this conditional statement, which means the condition corresponding to that else statement has to be false. So if u is not less than 71, that means u is greater than or equal to 71. Does that make sense? Okay. So so we'll jot down something. Okay. So I'm gonna start a document on the side so that I can document what I said. Okay. So we have gathered that we need u to be greater than or equal to 71. Okay. That's one requirement. But how do we get to line 48 to begin with? In other words, how do we get here? Regardless of whether the condition on line 48 is true or not, how can we possibly get here? Yep, if the condition of line 47 is true. Very good. Because line 48 all the way to line 52, that is a block that belongs to the then statement that started on line 47. So that means the condition of line 47, the condition that is specified on line 47, has to be true. So let me jot it down too. So u has to be less than 106. So so far, I do not see anything that is conflicting. In other words, so far everything looks good. But how do I get to line 47 to begin with? Okay, in other words, how do we even get to this part here, line 47? Is greater than, yes, go ahead, has to be false. So that means u has to be greater than or equal to 14. Okay, so these three conditions, they have to be true. All three conditions have to be true at the same time. Okay, in other words, okay, let me point out to which three conditions I'm talking about. I'm talking about these three. So if you can find a value for u that satisfies all three requirements, then it will work. So just pick one. Pick a value for u that satisfies both all three requirements. Note that greater than or equal to 14 is implied by greater than or equal to 71. So I guess 71 is going to work. Okay, so if you just say that, okay, let's assume u starts with a value of 71, then it's going to work. You will get to line 51, which then will give a value, y will be assigned a value of 2. So the next part of this is to trace it. Okay, so assuming that you can find such a value, then you have to trace it. So the trace in this case would start with line 44, and then you have to tell me that u is less than 14 is true, is false. Then you get to line 47. Then you have to tell me that u is less than 106 is true. Then you get to line 48, and you need to tell me that u is less than 71 is false. And then we get to line 51. In your trace, it has to indicate that y updates to a value of 2 at that point, and then we get to post. There's nothing to do after line 51 because line 51 is the end of the else of this conditional statement of the conditional statement that starts on line 48. But that conditional statement itself is the only statement of the conditionals of the then branch of the conditional statement that starts on line 47. But that conditional statement is the only statement inside the block, inside the else block, that corresponds to the outermost conditional statement. So that means by the time we're done with line 51, we're done. Get to post. That concludes the trace. So the actual trace is also in the key file that I am providing you. So if you scroll all the way down here, you can see this is the actual trace. Some people or some of the answers indicate, oh, we also go through line 45 and then we also go through line 49 or the other lines. That would be incorrect. Okay, we basically only evaluate line 44, the condition of line 44, the condition of line 47, the condition of line 48, and then we update y, and we're done. All right, so that's about it. Any questions about the solution, the key? Okay, all right. So the way I assigned your points is 4 out of 4 is a perfect answer. Okay, it means okay, I cannot find anything wrong or missing about the answer. 0 out of 4 is it means it is either missing or it is missing the point entirely. Okay, so those two are easy. Um, 2 is a really difficult one for me to decide whether someone is getting a 2 or not, but I'll explain a 3 first. So a 3 out of 4 means it is mostly correct with a minor thing that is wrong. So when I say it's a minor thing, it means it is probably a calculation mistake. Like when I calculated 5 minus 2, I said, oh, it's a 2. Okay, that's one of those things. Or it is a very minor omission, or the notation is wrong. Like people using braces instead of brackets. When now that we are talking about arrays, stuff like that. Okay, really minor things. A 2 out of 4 means whoever answered the question probably understand the most important part of the concept, but there are some attached concepts or related concepts that person got wrong. It is a conceptual misunderstanding of some kind. And so the answer is technically incorrect. But for the most part of what I really want to assess, that part is still okay. Okay. So there's always a core concept that I'm looking for with each part of the question. So if the core part is still okay, but everything else is wrong or missing or omitted, then it's a 2. So a 1 out of 4 means that part is missing. The core part is also incorrect or wrong, but I can see that the answer is still related to what the question is asking, okay, in a way. So it's not a 0, but instead it is a 1. So that's how I assign, 4, 3, 2, 1, 0 as basically grade points to each part of the question. Is that okay? A 4 is also an A B is a 3 is a B, a C is a C, a 1 is a D, and then the 0 is an F. So you can always equate the number to a letter grade, which, by the way, also equates to, okay, I know most of you do shopping online. A 4 is a 5-star review, a 3 is a 4-star review, and so on and so forth. So you can kind of think of it that way. What kind of product will you give a 1-star review? What kind of a product would you get a 2-star review, a 3-star review, a 4-star, and a 5-star review? So it's kind of like that too. All right, so that is all explained. Any questions about exam one? Yes. What about 90% again? No, what I said was I would use the 90 percentile of this class to become the new 100%, and I would scale everybody up to that new 100%. It's 90 percentile, which means, okay, so this class has about 30 people. Let's just say it's 30 people. So 90 percentile would be the third highest score of the class. Does that make sense? Okay. So let's just say this is an assumption. Okay. So let's just say that the first person got everything right. Okay. So it's 100%. The second highest score is 95%. And then the third highest score, for the sake of this argument, is 80%. So what I would do is I would consider the 80% as the new 100%. So that means everybody's score, original score, is going to be divided by zero point 0.8 to get to the new score. Does that is that okay? All right. So that's what I meant when I said I would use the 90 percentile score to become the new 100%. So the reason why I do that, in some cases, and I did it this time too. Okay, I did it this time. So the reason why I did that is because if I accidentally make a test too difficult, okay, then nobody's going to get 100%. Let's just say that the highest score is only like 70%. So does that mean everybody in this class is going to get a B or lower grade? No, I don't. I think that is not fair. Okay. So in that case, I would basically just go like, okay, I think a 90 percentile being the beginning of the A grade is fair. Okay. So that's why, that's the rationale behind what I just talked about. Is that okay so far? Okay. And by the way, according to the distribution, I think two people got perfect scores in this in this exam. And so the adjustment is only divided by, I think, like the third highest score was a 3.9, if I remember correctly. I cannot remember exactly, but the score that you see is already adjusted. Okay, all right. All right. Well, let's go ahead and take roll, and just so that we have a little bit of transition between the exam and binary search. So you guys cannot see it yet because I have not revealed the activity yet. So now I'm gonna reveal it like so, and the word is search. SEARCH, all lowercase. So while you guys are doing this, I'm gonna get ready for the binary search discussion. Okay. Okay, we are taking row right now, and this is the word for row taking. right. So since we are kind of doing a little transition here, let me ask you guys, what do you think of AI? To be more specific, LLM, the large language model kind of AI like ChatGPT. So what do you think of it in relation to, this class and the program, the computer science program? So what do you think of it? Mm-hmm. Okay. All right. Okay. All right. That's one answer. That's good. Yep. Go ahead. Oh, okay. I guess it's hard to tell. How about you first and then you? Yeah, go ahead. Mm-hmm. Mm-hmm. Okay. Okay. And how about you? Huh? It's on the whiteboard. Yes. All right. So I'm gonna do one experiment. Okay. This is something that I'm just doing now. I have not done it before, so we'll give it a try. So what I'll do is I'm looking at, let's say the first question of the exam one, and we'll go like, okay, what does it involve? I think it involves, how we deal with loops. Okay, there's no nested statement, so we're gonna go to the loop um, notes here. Okay, so we go here, and I hope you guys already realized that at the bottom here, there's a button. So if you want to copy the entire content of this document as a markdown file, you just click that button and then you click OK. And now I go to ChatGPT. So we go to ChatGPT, and why is that temporary? No, I don't need that to be temporary. Okay, so now we present the document. Okay, so we can say the following is the class notes for um, loops in an introduction to programming class. I will be asking a related question in the next prompt. So it is important to tell ChatGPT not to do anything about what I'm about to upload, okay? Because this is just providing some context, for the additional questions. So now I can do a Control V, okay, which pastes the entire thing. So that's the entire thing. It is a long document, so you can see how it just pasted the source code of the module. The entire module is now uploaded. So now I can ask it a question. And guess what question I'm going to ask it? Exam one of Question one of exam one. Okay, to be exactly, it's the one that you guys just looked at. Okay, so we'll go ahead and take a look at that one. So that is okay. I'm looking at the location of this one. It is a markdown file. I think I keep the markdown file in its own format. Yep, I did. Okay, very good. So this is called a markdown, document format. It is basically a very easy to understand HTML. So I can actually just gonna copy the entire thing, and I think that's all we need. So we just do a copy, and then we go to ChatGPT again, which is this one here, and I say, okay, here is a question related. Here is a question related to the uploaded document. Can you help me answer this question? Okay, and then you'll just give it Shift Enter a few times, and then Control V again. You'll paste the actual exam question, and we'll see what it can do. So it goes through basically the same reasoning that was explained. Choose the control structure. It tells me that it is a do while loop. inferring the assignment statement because every time U is changed, it is incremented in steps of 4. And now here's the code, and he got it right completely. Okay, so what do you feel about that? Now, this I did not know whether ChatGPT was able to answer this question or not prior to what I just did. Okay, so what do you think? Hmm? You're wondering the mechanism behind ChatGPT? Okay, so I can tell you ChatGPT is based on a trained neural network. And the neural network, the model, LLM, or the large language model, so the large language model is based on documents that it has read. So we are talking about everything that it can scrape out of the internet. Okay, and that's terabytes, if not petabytes of data. Yes, go ahead. Well, but it has to go through quote unquote the reasoning too, because I never gave it the actual solution. Yeah. So it had to go through at least something that resemble reasoning in order to deduce, oh, this is a loop and this is a do while loop instead of a while loop. But that's not a calculator thing. This is resembling human reasoning. Yep. But it's not something that the computer should be able to do. Prior to 2022, computers cannot do this. So it's only very recently that we have LLMs actually implemented that can do something like this. Okay, so I think what I really want you guys to think about is after you graduate in about 4 years, okay, after you graduate from a 4-year university with a bachelor's degree in computer science, okay, what is your plan at that point? I'm going to get rich because I will land a job that pays $120,000 or more because of inflation, right? That's generally the plan. So the next question you have to ask is what would justify my salary from the perspective of the employer? Exactly, but why? Because if AI can do programming already up to a certain level, then you have to provide some extra value because the employer would otherwise say, "Oh, I can just tell AI what program I need to write. I don't need to hire someone to write my programs. I just have to describe what the program is supposed to do, and boom, done." Right? And yes, it is expensive to get the most advanced model from OpenAI. I think it's $20,000 a month. Okay, but that's hardly it's like hiring two people. Okay, so if you're a large company and you need to do this kind of work like on a daily basis, it's like, okay, either I pay two people to do this or I can have the AI to do it. Okay, and don't forget there's something called Moore's law. Okay, Moore's law says your computational hardware or resources basically doubles every 2 years. So by the time you graduate from a 4-year university, computing resources, and I'm talking about networking, processing, and storage. Everything will be 4x of what we have today. Your phones will have 4 times the storage capacity, 4 times the processing power, and potentially 4 times the networking speed compared to what we have today for the same price. Okay, adjusted for inflation for the same price, you get basically 4 times the performance, which also means all the AI engines will also get 4 times the performance, right? Okay, so think about this. When the company pays you $120,000, they have to actually, the actual expense from the company's perspective is more like 160 because they have to pay employment taxes. They have to pay certain types of benefits and whatnot. So they actually have to pay quite a few more percent compared to what they act, what you quote unquote on paper end up with, and then you have to pay your own taxes too, right? So now you're looking at, oh, okay, so what would justify paying you basically from the company's perspective 150 or $160,000 a year to do the work that you're going to do. So I'm posing it as a question, okay, because I really do not have an answer. But as you go through all the classes in order to get your computer science degree, I think you should keep that question in your mind. Okay, for every class that you take, okay, you have to keep that question in your mind. It's like, okay, I need to learn all of this because what is the reason? Okay, yep. hmm The majority of people who graduate with a bachelor's degree is not going to be working on some high-end research project, which means, for those particular types of jobs, AI can probably do most of it already, if not all of it. Um, you can look up some news, okay? So you can look up Salesforce is one, and then Meta is the other one. And you can even ask, ChatGPT too, because ChatGPT can now um, go out and actually read news articles and then come back with an answer related to the news article. So you can look into Meta. Okay, Meta is one. So Meta fires 3,600 employees. Okay, that's enough to actually find me something. Okay, so you can look at this and you ask what kind of jobs are getting, are they, what kind of people are they firing from the company? Many of these are mid-level software engineers. So we are not talking about entry level. We are talking about mid level. And you might say, oh, maybe some people are just underperforming and that's why they got fired. Some of these people came back and say they never got a bad review. So they're not underperforming from the perspective of comparing to other software engineers. Okay. So you kind of have to think about that a little bit. Okay. You have to chew on this a little bit. The other one is Salesforce, which is also in San Francisco. So you look up Salesforce not hiring engineers. Okay, there we go. So let's see, what date is it? Okay, so this is last year, at the end of last year. Salesforce basically says because AI is already up to a certain level, they don't need to hire new people. Okay, that's what they said in December last year. And guess what they did earlier this year? They fired people. Not only did they stop hiring people, they actually started to let go of people because the AI is already being able to replace some of their current employees. So it's not like, oh, we don't need to hire additional people because AI is making everybody so efficient that we don't need to hire new people. No, AI is making it so efficient that they can let go of some of the existing employees. Yep. So keep that in mind. Okay. I'm not saying this to discourage people or to kind of depress people because this is factual. If I tell someone, okay, this is hypothetical, I'm not saying that at all to anyone. Okay. If I just, go to one person and go like, you're dumb. Okay. That would be wrong. Okay. Because it is an assessment on my part. It's an opinion. Okay. It is not factual. But what I am telling you here, everything is factual. You can fact check everything that I said. So I'm telling you, what the reality is at this point, and then giving you a little bit of tool to kind of project what the future will be like in 4 years because of Moore's law. If not anything else, just because of Moore's law, things, computer or computational resources will be quadrupled compared to what we have today. All right. So from your perspective, what do you think is the focus when you are going through classes? Hmm? Sorry? What is your focus? In other words, what is the importance? What are the important stuff that you need to think about when you are taking classes in the computer science track, in the computer science program? Hmm? How to run the code is a very specific skill. Okay, it's fairly basic. It's the only thing that we talk about in this class, but it is a foundational thing. Yep. Understanding algorithms. Okay, that's good. But guess what? AI already understands algorithms. Okay, maybe. Okay, yes. Mhm. 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 Exactly. So how do you do that? How do you make yourself invaluable? So Sam Altman, okay, who is Sam Altman? Okay, the answer is right there. He's the CEO of OpenAI. Okay, so OpenAI is one of the main AI companies, developing LLMs or large language models, along with some other AI models. So somebody asked him about what is the most valuable skill set. Okay, so most valuable skill. Okay, is asking the right question. Yep. But how do you learn to ask the right question? So this is not a class in psychology or philosophy, so I'm not going to answer that question directly. But you have to kind of think about it. Okay, how to learn by yourself is important. Critical thinking is important. Okay, so if you're new to this term, it's called critical thinking. So look up the term, because it is one of the most useful skill that we are still outdoing computers or outdoing AI is critical thinking. Another one, which is I think is a misnomer, is called creative thinking. Okay, creative thinking. Okay, have you guys heard of the term of somebody is thinking out of the box? Have you heard of that term? Okay, it is not true. Everybody is thinking inside some kind of a box. The only question is, what is the size of the box and what is the shape of that box? Everybody has a box. The reason why we have a box is because of the way we learn. When if I give you guys a lot of busy work to do, like, oh, trace this algorithm, trace this algorithm, trace this algorithm, and all the algorithms are very similar, then you would automatically make an association that is not supposed to be there. So if I say, okay, A goes to B, A goes to B, A goes to B, and then the next question is, oh, I'm starting with A, where am I supposed to go? B, right? Because you have this repeated exposure of B always follows A. But did you question why that is the case? Why is B following A? So every single instance of B following A may be for a different reason. So if you look into the reasoning of why B follows A every single time we have, oh, B follows A, then the next time I ask you, this is A, what follows A? What is the next thing that we need to do? You go like, oh, it's not always B. I have to look at the mechanism, okay? What is the actual condition? It may be C, it may be something else, because you're now looking at the reason of why B follows A for each and every single case where B actually follows A. You're not just remembering that, oh, this is my observation. I'm just generalizing my observation that B always follows A. You're asking, but why does B follow A in each and every single case? They may be different. Does that make sense? So the way professors design out homework assignments, I think has a big influence on whether we ended up putting a box on your head. But it is also something that you can do to help to make sure that you don't put a box on your head. Because if you look into the reasoning why things happen the way they do, instead of just making an observation of, oh, this always follows that, then you are already helping yourself to make at least make your box bigger. And that is the one thing that we are still having an advantage over AI, because AI has a pretty uniform box over its head because of the way it is trained. Because AI or LLM is trained based on human data. So basically, it is very good at imitation because it has a huge knowledge base, and it's very good at imitation. But in terms of solving new problems based on and understanding why things happen, I don't think it can quite match what people can do. But what people can do does not mean you and I can do it automatically. You need training to do that. It's just like asking me, Tag, can you run a marathon? I go like, no. But can humans run marathon? Yes. The human body is actually exceptionally good at running marathons. But I cannot run a marathon because I'm not trained to do it. Okay? So you have to train your mind to beat AI. Okay? And I think that would be the focus, is how do you do that? I don't have a universal answer. Okay? Yep. All right, so I think that's enough of a digression. I hope you don't do not think that I just wasted some of the time of this class. So shall we go back to binary search? Okay. All right. So we're going back to the module that talks about binary search. So with binary search, the algorithm is described here. Okay, but it's best to describe it using an example first. So examples are useful for us to get a better understanding or get a more intuitive understanding of something. So it's good. It's a good starting point, but it is not a very good learning mechanism in terms of, oh, I just need to remember these things. All right. So I'll give you an array that is sorted, and it has, let's say, 7 items. Okay. So we have 2, 2, 3, 7, 10, 10, and so let's see, there are 20, there are 6 here, 20. So I'm not even bothering. Yep, go ahead. The module. Oh, I may not have released it. Oh, it is here, but it's not released. Okay, I apologize. Oh no, that's the homework. It's searching in an array. It is already. Yep, yep. It's already there. Yep. So I typically just kind of move down, in terms of the topics. Okay, once I'm done with one topic, I just move on to the next one. All right. So getting back to this thing, let me go back to my, where is it? Supernote. There we go. Okay. So let's say this is an array. Okay. In other words, if I need to, this is a bracket 0, blah, 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 and this is the last one, which is a bracket 6, because we have 7 elements. So the last one is named a bracket 6. Are we good so far? Okay. So we have an example. And let's just say that I'm looking for something that is not even in the array, and I need to confirm that it is not in the array. Uh, let's look for let's look for some extreme case, like the value that I'm searching for is 21. Is that okay? So even if I use the optimization that we talked about on Monday, I would still have to go through the entire array to realize that 21 is not a value in the array. Do you still remember the optimization that we did on Monday on the original search algorithm? We can exit a little bit earlier, right? If the value that we are searching for is less than the element that we're comparing to. That was the conclusion from Monday. But this time looking for something like that's 21, which means even with that optimization that we talked about on Monday, we would still have to go through the entire array. So binary search is weird because it starts from the middle. So for every step in binary search, we have to keep track of the beginning of the array and the end of the array that might contain the value that we are searching for. So the beginning initially is going to be here. The end is here when we start. In other words, everything in between can potentially contain the value 21 initially because we have not done a single comparison. There's no way for me to tell, oh, it cannot be here, it cannot be here, and so on. So that's the initialization. Does that make sense? The first comparison is going to be start from the middle. Okay, so I'm going to compare 21 to the 7. So 21 is 7 is less than 21. That's my first comparison. Well, that looks kind of odd, Tech. We are not starting from one end or the other end. We're starting in the middle. But if you start from the middle, just knowing that 7 is less than 21, which part of the array can I rule out as something that might contain the value of 21? So let me ask you. This is index 1, 2, 3, 4, 5, 6, 7. Which elements can I rule out right away with one single comparison? 0, 1, 2, and 3 itself. Okay. So that means after one comparison, if I keep track of which part of the array may still contain the value of 21, it will start here and it's going to end here. After one single comparison, I only have 3 items left that might contain the value of 21. I have just ruled out more than one half of the array. Is that okay? So this is really important, right? So now I can reuse the same approach. Of the remaining portion of the array that might contain the value of 21, I choose the middle of that. Which index would be the middle of what is left of the array? It's 5, okay? Because between 4, 5, and 6, the middle is going to be 5. That is correct. So we look at this and we have another comparison. Okay, 10 is less than 21. So now I can also rule out 4 and 5. I can rule out index 4 and index 5. So the only thing left is just one single element, which is index 6. So I need one more comparison to say, oh, 20 is still less than 21. Then I have a conclusion of 21 is not even in the array. So that's only how many comparisons? 3 comparisons. Okay. In 3 comparisons, I can rule out all 7 items in the array. Is that okay? And the magic of how this works is every time we have one comparison, we are ruling out one half or a little more than a half of what is left or what can potentially still contain the value that we are searching for. Yes, like a then you can choose any one of the two as quote unquote the middle. You're free to choose which one. Yep. hmm So the question was, what if we had 8 elements to start with? In other words, the indexes go from 0, 1, 2, 3, 4, 5, 6, and then a 7. In that case, both element 3 and element 4 can be considered as the middle. It doesn't really matter which one you choose. All right. So let's try to pick something that is in the middle and is also still missing. Okay. So is it okay for me to erase part of what I have written? Okay. All right. So I'm going to erase that. If you want to get back to it, you can always go to the recording to get back to what we had. Okay. Nope. Nope. Ah, okay. Mm, Just have to put a big old lasso over the things that I need to erase and then go back to the pen tool. Okay. So let's say this time I'm looking for, um, oh, I also erase all the values. Okay. That's not what I intended to do, but okay. Let me go back and re-erase the portion that I need to erase. There we go. All right, that's good. That's exactly what I want to do. All right, so this time, let's say we want to find a value of 8. So you can see that 8 is missing in the array, but it's sitting right about in the middle between 2 elements. Okay, between the 7 and the 10. 8 is if 8 was here, it's going to be there, right? But it's not. So now we go through the same algorithm. Okay, the first one that we compare to is the 7. So now we say, oh, okay, 7 is less than 8. So initially, the entire array may contain the value that we are searching for because before the first comparison, anything in the array may have the value that we are searching for. But after we know that 7, which is in the middle of the entire array, is less than 8, which part can I rule out? Same as last time, right? So the first 4 elements can now be ruled out. So that means the part of the array that may still contain the value of 8, is going to be index 4, 5, or 6, just like last time. Is that okay? But this time I'm going to choose element 5 also to compare to 8. But the conclusion is different this time because 10 is greater than 8. So now, which elements can I rule out because of this comparison? 5 and 6. That is correct. So at this point, I only have one element left that may contain the value of 8, which is the element at index 4. So I need one more comparison right now and say that, oh, this is also a 10, which is also still greater than the value that I'm searching for. And now I have the conclusion that 8 is not matching the value of any element in the array. Is that okay? So the ruling out may apply to the left-hand side, it may apply to the right-hand side. So the important part is with every iteration, I have to keep track of the beginning of the array that might contain the value that I'm searching for and also the end. So that means in this case, I call this variable b, which is the index of the first element that may contain the value that I'm looking for. And I call this e for end, beginning and end, right? So e is the end of the range of the array that might contain the value that I'm searching for. By adjusting b and e, okay, b and e, and then this time B and E are really the same. By adjusting B and E, I can keep track of which part of the array may still contain the value that I'm searching for. And that is the mechanism of binary search. So are we good with the concept? Okay, with 5 minutes left, I cannot really go through a trace. There's not enough time to do it. But what I can do is to go back to the module and kind of at least point out, what which part of the module talks about this is binary search, and this is the concept, and this is the actual algorithm. So this is the actual algorithm, and oh, okay, this is my bad. This is not supposed to be a dollar sign. It's supposed to be a B. Let me fix that first because I don't like it when there's a mistake in the notes. Because I had to translate everything from pseudocode to C code. So this is supposed to be a B, commit change. And it's going to take it about a minute to refresh. So before that, okay. Oh, okay, it's on the other side. There we go. So this is the algorithm. This is going to fix, it will be fixed in about a minute or so. So what you can do is to go through the trace. This is an explanation, by the way. Okay, that this is a dissection of the algorithm. So what I can do is to give you kind of like a homework assignment, okay? And we can use the same example that was displayed earlier, which is in my super note here. Okay, so this can be not a homework assignment per se, because I really want to trace it in class once, okay? But I think you guys can do this now, okay? Because the algorithm does not involve something that we have not talked about. So let me get rid of the things that are specific to this example. Okay, so we'll get rid of all of this. And I think I got rid of something else that I don't need to. Okay, there's a one here. So I want you guys to look at this algorithm, and um, I cannot remember. It doesn't matter. It doesn't matter. So this time I want to look for 2.5, which is also missing in the array. So I think you need to keep track of n. N in this case is 7 because there are 7 elements in the array. So um, we have a spring break, right? So we are not going to meet for another 7 plus 5 days, which is 12 days. So I won't see you guys in 12 days. So within those 12 days, if you can find some time to work out this particular example by applying the binary search algorithm, that will help greatly. Okay, when we come back after the spring break, that will help us, to kind of get back into binary search, because just by doing this yourselves, you are basically keeping keeping the engine warm, so to speak, by kind of retaining the material that we have talked about. So is that okay? Can I rely on you guys to kind of do this? It's not a homework assignment. There's no score associated with it, but I just want you guys to be able to have something to do so that you can keep thinking about this. Are we good? All right. So I think for the first time of this entire semester, I'm going to let you guys go 2 minutes early. So you can complain to the dean and go like, I demand my money back because tech let us go by early by 2 minutes. I'll see you all after the spring break. So have a good spring break, have fun, but still at the same time, don't forget to kind of maintain your knowledge of this class. Okay, that's important. Okay. So there's a class that needs to come in about 10 minutes. So I'm gonna, clear away, from this classroom, but you guys can follow me to my office. Yep. Yep. Uh-huh. Yes, it dropped a little bit because there was one additional um, exam that I scored after publishing this grade, and that person got a perfect score. So that changed the 90 percentile score. Yep. hmm you can look at the score that you get out of it, and okay, you can either follow me to the office, I can take a look there, or you can send me an email so I can take a look at it. Okay, okay, hmm okay. So you can follow me to the office, or you can send me an email. Either way works.